Assalamu alaikum, my dear students. Welcome to your chemistry second paper class of standard 12. Today I will discuss about Faraday's first law of electrolysis. Before that, at first I have to discuss some terms which are used in electrolysis, such as electricity. Electricity is just the flow of electrons through any conductor, and its unit is coulomb, which is denoted by capital C. Another term, strength of electric current. This is actually the rate of passage of electric charge through a conductor is called strength of electric current, and its unit is ampere, and it is denoted by capital A. So ampere equal to, we can write coulomb per second, and from this relation we can easily define ampere like this way: the amount of electrical charge flowed in 1 second through a good conductor is called 1 ampere. And also we can define coulomb from this relation also: the amount of electric charge which passes through a conductor when 1 ampere current is passed for 1 second is called coulomb. So if we remember the relation ampere equal to coulomb per second, so we can easily define ampere and also coulomb like easily. Now Faraday, the total charge of 1 mole electron is called 1 Faraday, and it is denoted by capital F. So what is 1 mole electron? Avogadro's number of electrons, and we know that the charge of 1 electron is 1.66 into 10 to the power minus 19 coulomb. So the amount of 1 Faraday will be Avogadro's number into the charge of 1 electron, total 96,500 coulomb. So 1 Faraday equal to 96500 coulomb. So you have to remember this value. What is the value of 1 Faraday in coulomb? Now electric potential, the amount of work which is done to bring an unit positive charge from infinity to a point in an electric field is called electric potential at that point. That means the amount of work which is done to bring a unipositive charge from infinity to a electric field is called electric potential, and its unit is volt and its symbol is capital V, and electric potential equal to work done divided by amount of charge. Now I will discuss about Faraday's law. Before that, follow this picture. This is the picture of electrolysis process. Already you have gathered some knowledge about electrolysis in previous classes. So what is happened actually in electrolysis process? To done electrolysis process, there is used a electrolytic cell. This is the electrolytic cell, and these two are electrode. One is anode and another is cathode, which are connected with the electric source with positive and negative terminal point, and there is used electrolytic solution. This electrolytic solution may be aqueous solution of ionic compound, or it can be molten state of any ionic compound. Now what is happened here? When electricity is supplied, then what is happened? The ions which are freely move inside the electrolytic solution, they are actually reached to the different cathodes. Cations are reached to cathode and anions are reached to anode, and their oxidation and reduction reaction occurs. And in anode always oxidation reaction occur, and in cathode always reduction reaction occurs. So due to occurring oxidation and reduction reaction, each electrode there is actually deposited or dissolved some amount of substance. metals through the reduction process. Metals are deposited in cathode, and through oxidation process non-metals are deposited in anodes. So the question is here, what amount of substance is deposited or dissolved in each electrode? And about that, scientist Michael Faraday said that this amount of substance is directly proportional to the amount of supplied current, and this is known as Faraday's first law of electrolysis. So he stated that the amount of a substance deposited, evolved or dissolved at an electrode is directly proportional to the amount of electricity passed through the electrolytic solution. That means the amount of deposited substance is directly proportional with the amount of supplied current. So if the amount of substance is denoted by M or W, in your book that is expressed in W, and the amount of current is expressed in by Q, then we can write according to law M is directly proportional with Q. Now we know that Q is actually what? Q is actually Q equal to IT. IT means T is time and I for amount of electric charge in ampere. So Q actually the amount of electric charge which is passes through the conductor per unit time. So we can write M proportionally IT. Instead of Q we can write here IT. And since there is proportional, so we need a proportional constant. So here we use a proportional constant, that is J, capital Z, and this Z is called actually electrochemical equivalent of the substance. So what is electrochemical equivalent? The amount of substance deposited or dissolved by passing 1 coulomb of electricity through the electrolytic solution or through the electrolytes is actually known as electrochemical equivalent. The amount of substance which is deposited or dissolved in each electrode by passing 1 coulomb electricity, that amount is actually called electrochemical equivalent of that substance. How can we determine the electrochemical equivalent? Like this way, electrochemical equivalent actually gram atomic mass of deposited element divided by NF. Gram atomic mass of deposited element divided by NF. What is N? N is valency or oxidation number. That means the number of transferred electron, and F is for Faraday. Now, for example, electrochemical equivalent of hydrogen. How can we determine? Follow here. The gram atomic mass of hydrogen is 1 and valency is also 1, and Faraday's value is 96500. So its electrochemical equivalent will be this amount, and unit will be gram per coulomb. Another example, electrochemical equivalent of silver. Gram atomic mass of silver is 108 and its valency is also 1, and its 1 Faraday is this. So we can easily determine the electrochemical equivalent of any element from this relation. Now I will discuss about the determination of amount of deposited or dissolved substance in electrolysis from Faraday's law. That from actually here I will show experiment. Follow the picture. This is the electrolysis process. Here as electrolytes there is used molten aluminium oxide. Molten aluminium oxide, that means aluminium oxide in melted state, liquid state. So inside the electrolytes there is present actually aluminium ion and oxide ion, and this is 2 electrodes which are connected with the battery with positive pole, that electrode is anode, and the connected in negative pole connected electrode is called cathode here. This is ammeter. Ammeter actually used to measure the supplied current. Here is also a stopwatch to measure the time. Now when the current is started to supplied, then what will happen? Anode, positively charged electrode, so it attracts what? Negatively charged ion, that is anion. So when oxide ions are recessed to anode, then what will happen? It releases electrons and converted into oxygen atom, and combine two oxygen atoms together produce what? Oxygen gas. So here oxide ions releases the electron and converted into oxygen gas. We will finally get oxygen gas from anode, and the electrons are flow from the circuit and reach to the cathode. And in cathode, what is happened? Cathode is negatively charged electrode, so cations are reached to cathode, aluminum ion are reached to cathode and accept 3 electrons and converted into metallic atom. So from cathode actually there is deposited aluminium metal. Aluminium metal, this is the aluminium metal. Now, and here current is measured, how many current is supplied from the circuit and through the circuit, and how many times is needed to deposit the aluminium metal. So from this measurement of current and time, we can easily calculate the amount of deposited metal. So in this process, or through this process, actually following the Faraday's law, we can easily calculate the amount of deposited or dissolved substance. Now I will discuss problems based on Faraday's first law. For example, how much nickel will be deposited at the platinum cathode when a current of 5 ampere strength is passed through nickel nitrate solution for 30 minutes. Remember the formula, M equal to Z IT or W equal to Z IT. So what is given here? Here follow this I, the amount of I, current is given 5 ampere. Also T, time, there is given 30 minutes. You have to convert it into seconds. And so easily you can calculate here W, because you also can calculate the value of Z from this here. So follow this, I equal to 5 ampere, T equal to 30 minutes, convert into seconds. And Z, how can we calculate? Atomic mass of nickel 58.7 divided by valency of nickel here 2 divided into 1 Faraday. So putting this value from the formula, we can easily solve our problem, and we will get the amount of nickel, that is 2.737 gram. Follow the another example. In a metal sulfate solution, 0.5 ampere current is passed for 1 hour to deposit 0.59 gram metal. What is the gram equivalent mass of that metal? It is just a little bit different, but from the given value, at first we can calculate electrochemical equivalent of metal. Follow this. Here is given what? I, the value of I, T also, and W also, 0.59 gram. So putting this value, easily we can calculate at first electrochemical equivalent of the metal mentioned in the math, and we get electrochemical equivalent is this. Now gram equivalent mass is related with the electrochemical equivalent like this way. Gram chemical equivalent mass equal to electrochemical equivalent into Faraday. You have to remember this. So now easily you can determine the gram chemical equivalent mass of the metal multiplying electrochemical equivalent with value of 1 Faraday. and you will get 31.63 gram. So this is the answer of the given problem. Now another example, how much coulomb of electricity is required to extract 20 gram calcium metal by electrolysis of melted calcium chloride solution? How much coulomb of electricity is required to extract? So here is given W and Z we can calculate. So just we have to determine the Q. So what is given here? Z we can calculate from the math, and W, so we can easily calculate the Q. How much coulomb? So easily we can solve the problem. Another example, 3.7 ampere current is passed for 6 hours in 0.5 liter volume 2 molar nickel nitrate solution. What will be the concentration of that solution after electrolysis? This is very important, man. For your exam, because this type of maths already came in board exam. So here this is not difficult, just in this maths you have to do in 2 steps. In first step you have to determine first amount of deposited metal. Follow here, there is given I, also T, Z also we can calculate. So easily we can from this given value we can easily calculate the amount of Z at first, and also there is amount of W, and also there is given concentration of the electrolytic solution, that is 2 molar, and volume is 0.5 liter. So how can we solve the problem? Follow here. At first we will calculate from the Faraday's law amount of deposited metal, that is 24.31 gram. Now previous amount means before the electrolysis process there is given the volume and also concentration. So from volume and concentration we know that mole equal to molarity into volume, by molarity equal to mole per volume. You have known this formula. So from this relation we can easily calculate the amount of metal previously which is present in this solution, 0.5 liter 2 molar solution. So this amount is actually 58.7 gram. 1 mole metal is present in this solution. So 1 mole means 58.7 gram nickel. Now after electrolysis, that means due to electrolysis process we have seen here 24.31 gram nickel is deposited. So after electrolysis process, from previous amount, if we subtract this electrolyzed amount, then we will get this amount. So now this amount is actually present inside the solution, so we can easily now calculate the concentration. You have to convert it into mole dividing by atomic mass. Now concentration is what? Molarity equal to mole per volume. So this mole divided by volume will be same. So 0.5. So now we will get molarity or concentration equal to 1.172 molar. So previously the concentration of solution was 2 molar, and after electrolysis, since the some amount of metal is deposited, for this the concentration must be less, and that is 1.17 molar. So like this way you can easily calculate the concentration of the electrolytic solution after electrolysis process. So my dear students, like this way we can easily solve the problems. Now another problem, in nickel ion solution 0.1 ampere current is passed for 160 minutes to deposit 0.295 nickel metal. What is the charge on nickel ion? Here you have to determine the charge. There is given what? I, T, W also. So at first we have to determine the Z. We have to determine Z. Now what do you know? Z equal to what? Gram atomic mass divided by charge into Faraday. So we know the value of Z. and other values are there. So from this relation we can determine the amount of charge. So like this way in different maths we have to calculate different factors. Sometimes we have to determine the current I, we have to determine the value of T, or we have to determine the valency or charge or electrochemical equivalent, etc. etc. But if we understand the Faraday's law clearly, then we can easily solve the different problems. So my dear students, you have to practice a lot of maths, and there are a lot of maths present in your book, and in different books huge maths are there. So please, you will practice more and more, because when you will practice more maths, then you will be skilled in calculation, and in that time you can do a math, or you can solve a math in very less time. Just I have kept here some extra maths just for your extra practice, but this is not enough for your perfection. So you have to must practice more and more. But here just I have kept here 5 maths. You practice this and you will must show your calculation in my personal ID and send in my personal ID. So today up to this, and I am coming soon with new topics. Up to that, thank you. Goodbye.